We have a label here, and we see straight away it's tablets. There are 100 tablets in here, and each one of those tablets contain 250 micrograms or 0.25 milligrams. These are equivalent. You could even double check if you wanted. So grams, milligrams, micrograms. If we were converting that milligram into microgram, we would multiply by 1,000 or walk the point 3 places. So that would be 1, 2, 3. That's the new point. So we would say this is 250 micrograms. Yes, it does match, of course. It's in the label of the drug. Why would they give us both? Just in case the order had been given either in micrograms or milligrams. So let's check how our order was actually given here. In the chart we see 0.5 milligrams. So that's the one we want to use. We don't need to make any conversions because it's already there for us, 0.25 milligrams. So let's see, what the patient needs is here, our want. What the drug tells us is here, the 0.25 milligrams, that's part of our have. But there's something missing, we need the third number, or we need the have always has those two quantities. And there it is. Not the 100 tablets, but each one of the tablets contains 0.25 milligrams or 0.25 milligrams per one tablet. Each one of those 100 tablets contain that. So draw the box, always starting with the have, because then two quantities are in. It's a lot easier to just place the third quantity, and we can say 0.25 milligrams in each one tablet. So the have is in. All we need to do now is find the place for the want, which in this case is milligrams, so it will need to sit on the top to match milligrams on the left. If we had tablets, of course, we would have added that to the position on the bottom. So what happens here? Quick mental calc, 0.25 goes to 0.5, making very clear that this is 0.50 actually. 0.5 half is the same as 0.50. 5/10ths or 50/100ths, they are all equivalent. And it's easier to visualize it like that because now we can tell that 0.25 goes up to 0.50, and it goes up because it's been multiplied by 2. It's doubled. So it means that one tablet will need to be doubled as well, and we are now expecting an answer of 2 tablets. Let's see if we do get that doing the calculation. So we use the box, the main diagonal, meaning that one that has the 2 quantities. The other diagonal doesn't help us because you don't have that third quantity there. So multiply 1 here, 1 times 0.5, and then divide by the 0.25. So this is 0.5 divided by 0.25. We can even use the calculator straight away because we have already done our mental calculation. We know the answer should be around 2, if not exactly 2, and that's what we get, 2. 2 what? This part of the box needs to match with tablets. So this is how much the patient will receive in each one dose. The second question says, how many tablets would you need for a 24-hour period? So let's come back here and check in the chart what we have in terms of how the directions, how we deliver it. Every 4 hourly. So, or sometimes we see that written as every 4 hours or just 4 hourly. That means that for each lot of 4 hours, we give 1 dose. So what we need to discover is how many lots of 4 hours are there in 24 hours. So you probably do that in your head, but what you actually trying to do is dividing the 24-hour period into lots of 4s, which gives you 6. And that 6 means 6 times a day, or 6 doses in 24 hours. So what do we need to do then? Well, if we know it's 2 tablets per dose, but we need in 24 hours to give it 6 times, all we need to do is multiply 6 by 2 and get 12 tablets in 24 hours.